Okay, this is question 7 of the homework, and there's two parts to this question. The first part, we're given a speed of 11 meters per second, and we have to find the time it takes for this particle to travel from A to C. And what we'll do is we'll just look at the horizontal component, and then we have to show in the second part of this that this distance here, or this point here where we hit, is 0.63 meters below point T. The second part of the question, the speed is now increased to V, and the particle then hits at T, so it goes through a slightly higher trajectory, and we need to find the value of V. So we'll look at the first part first, and as always with these questions, we're going to split the velocity component here into its horizontal and vertical components. Okay, we know the distance from point A to point C over here is 10 meters. So simply looking at the horizontal displacement, we can say that the time to travel is equal to the distance divided by the speed. Distance we know is equal to 10, and the speed in the horizontal direction is 11 cosine of 30. One divided by the other gives us 1.0497 seconds, and that then is approximately equal to 1.05 seconds. So there's the first part of the question. Now the next part of the question is basically to demonstrate that this point C is 0.63 below the point T here. So we're going to look at the vertical displacements and the vertical velocities. So we're going to start off with a datum here, and we'll basically measure all our displacements from this datum here. And so we're going to look in the vertical direction, and we're going to imagine our inputs to our equations of motion, U, V, A, S, T. So the initial velocity U is the 11 sine 30. The final velocity we don't know. The acceleration is minus 9.8, and it's negative because it's going down. The displacement we don't know yet, and the time we've got from the first part of the question. We'll use this upper value here so we don't lose any rounding errors. Okay, now what ties together displacement, acceleration, initial velocity and time? Well, S equals ut plus 1/2 at squared. And all we're going to do now is substitute our values into this. So the initial velocity is 11 sine 30. The time is 1.0497. Minus now, because I've got a minus over here, minus 1/2 times 9.8 times 1.0497 all squared. Substitute the values in, and we get the displacement equals 0.37. 374. So the height above the base the height above the base is going to be the 1 meter up that we've got up here, up to the datum, plus the 0.374. So it's going to be 1.374. So the distance below T is 2 minus 1.374, which equals 0.625 and so on, which is approximately 0.63 meters, which is what we're looking for. Okay, now the second part of the question, what we wanted to do was find the value of v such that when we fire this particle it hits at some point t up here, which is 2 meters above the ground. Okay, so again on this one we're going to tackle it the normal way. We're going to look at the horizontal components and we're going to look at the vertical components separately. So in the horizontal direction, we'll look at that first. In the horizontal direction we can get the time. So we can say that the time is equal to the distance, which is the 10, divided by the horizontal speed, which is v cos 30. And so we get 10 over v cos 30. Now again we'll now look in the vertical direction. Again we'll measure all the displacements from the datum here. So our displacement from basically from this datum up to t is going to be 1. So in the vertical direction we've got u, v, a, s and t. So the initial velocity is a v sine 30. The final velocity we don't know. The acceleration is minus 9.8. The displacement is 1. And the time we've got from the first part over here, which is 10 over v cosine of 30. Okay, and we now ask ourselves, well, what ties initial velocity, acceleration, displacement and time together? Which one of our equations of motion? Well, that is going to be s equals ut plus 1/2 at squared. And now again substitute the values in. The displacement is going to be the 1. The initial velocity is v sine 30. The time is 10 over v cos 30. The acceleration is negative, so this becomes minus 1/2 times 9.8 times the square of the time, which is 10 over v cos 30 all squared. So we can simplify off. These v's are going to cancel. Sine over cos is tan, so that means I've got 1 is equal to tan 30 times 10. Half of 9.8 is 4.9 minus 4.9. 10 squared is 100 divided by 100 there, divided by v squared times cos 30 all squared. Okay, we'll make v the subject to the formula. So we'll just rearrange. We'll take all this onto that side, and I'll take the 1 onto the other side. So I've now got, multiply the 4.9 by 100, so I've got 49 divided by v squared times cos 30 squared equals 10 times tan 30 minus 1, and I'll invert both sides now, so we get now v squared cos 30 squared divided by 49 equals 1 over 10 tan 30 minus 1. So a lot of boring algebra in this question. Multiply through by 49, divide through by cos squared 30, so we get v squared equals 49. In fact, that should be 490, so apologies on that. 490 divided by cos 30 squared times 10 tan 30 minus 1, and v is going to be the square root of all of that. So when we stick these values into the calculator, we get 136 11.86, and we take the square root, so V then equals 11.69, which to three significant figures is 11.7 meters second to the minus 1. So there's my final value for V. So let's just quickly go over that again. So we split the problem into two halves, a horizontal part and a vertical part. In the horizontal direction we get the time first, time is distance divided by the horizontal velocity. Obviously we're assuming here that there's no air resistance, so this velocity here remains constant, gives us an expression for time. In the vertical direction we use our equations of motion. We take a view of what we've got. We've got V sine 30 as the initial velocity, the initial vertical velocity. We don't know the final velocity. We know the acceleration due to gravity is minus 9.8 because we're going down. We know the displacement is 1. We've got the time from the first part of the question, from the horizontal component. Substitute the values in, then just basically lots of boring algebra as we plow our way down to make V the subject of the formula and get the final answer. Okay, the question also asked, why would there be a range, or why is there a range of values of V that that would allow the particle to hit this target over here? Well, there's going to be a range because the particle is going to have a size, and this is going to have a size. So there'll be a small range just due to the difference of sizes of the two particles.